Hi, Mr. Wright here, and welcome to this video, which is a walkthrough of the solutions to Summer 2023 Paper 1H. In the description of the film, you'll find a link that enables you to download the exam paper so you can have a go at it before you watch the film and then watch the film, or of course, you can work through the paper as you watch the film and work alongside me. Also in the description, you'll find links to different parts of the film, so if you only want to watch a certain question or two, you can click through and access those parts of this long film without having to watch the whole thing. And at the end of the film, you will find a short clip which details the grade boundaries for Summer 2023. So you can see how you would have done if you had been sitting your IGCSE exams in Summer 2023. Okay, let's get on with the maths. The number of goals scored by A, S, and K are in the ratios 2 to 5 to 8. Simon S scored more goals than A. Work out the number of goals scored by Kath. A, S, K, 2 to 5 to 8. Simon scored 12 more goals than Arjun. Well, in my original ratios, Simon has scored 3 more goals than Arjun. So if Simon scores 12 more goals, then each of my ratios must be multiplied by 4. Work out the number of goals scored by Kath. 8 fours are 32. So 32 goals were scored by Kath. The table gives information about the number of minutes that Abby spent walking each day in September. Number of minutes, frequency. So she spent 5 on 5 occasions, 5 days, she walked between 0 and 30 minutes, for example. Work out an estimate for the total number of minutes that Abby spent walking. Well, I'm going to need the midpoint because these 5 days here when she walked between 0 and 30, I don't know how long she walked each day, so I'm going to assume that that's 15. I'm going to assume that each of these 6 days she walked 45. Each of these 8 days, halfway between 60 and 90, 75. Each of these 9 days, halfway between those two is 105. Halfway between 120 and 150 is 135. So to work out the total number of minutes that she walked, if she walked 15 minutes for 5 days, then that's 5 times 15 minutes, 75 minutes. 6 times 45, because on 6 occasions, I'm assuming she walked 45 minutes. On 8 occasions, 75 minutes, 8 times 75. On 9 occasions, she walked, I'm assuming, 105 minutes. And on 2 occasions, she walked 135 minutes. So her total number of minutes that she walked are 75 plus 270 plus 600 plus 945 plus 270 gives me a total of 2,160 minutes. So my answer is 2,160 minutes, and it wants the answer in minutes, so that's all good. Nanette buys 60 notebooks for a total cost of 780 dirham. So we're in Morocco, I think. 60 notebooks for a total cost of 780. She sells 70% of the notebooks for 22 dirhams each, and the remaining notebooks for 19 dirhams each. Work out Nanette's percentage profit. Give your answer correct to 3 significant figures. Right, well, if she sells 70% of the books for 22 dirham each, well, 70% of 60 is 42. So she sold 42 for 22 dirham each, and she sold the remaining ones, 60 minus 42, so 18 left. So she sold 18 for 19 dirhams each. So how much money did she take in total? Well, 42 she sold for 22 dirhams, and 18 she sold for 19 dirhams. So let's work out how much money she sold them for in total. So in total, she took £1,266. Now, what's her profit going to be? Well, her profit is, sorry, it's not pounds, is it? It's dirham. And her profit is what she received, subtract what she spent, giving her a profit of 486 dirham. So her percentage profit is the profit over the original multiplied by 100. And I'm asked to give that answer to 3 significant figures. So my answer to 3 significant figures is going to be 60.3%. And that is her percentage profit, correct to 3 significant figures. Question 4. The diagram shows a sketch of triangle A and triangle B. Given that triangle A has been translated to give triangle B, work out the value of D, the value of E, and the value of F. Well, let's have a look. We've got this point here being translated to give us this point here. So given that one of the points is -7, 2, and that has been translated to become 6, 12, then the shape has been translated by the vector 13 along -7 to 6 and 10. So that is the vector of translation. So if we have a look then at this point here, let's see where this point will end up. Well, obviously it's ended up there. Now it was -11 -5, and it has to be translated by the vector 13, 10. So the new x-coordinate is going to be -11 plus 13, 2, and the new y-coordinate is -5 plus 10, which is 5. And it's been translated to the point 2D, so D must be 5. Great. Okay. I'm also asked to work out E and F. Let's have a look at this point here. That point begins at F -3, and it translates to 9, E. Now, the y-coordinate, the new y-coordinate is E. So E must be 10 more than -3. So E must be 7. Now, the new x-coordinate is 9, and it started as F. So F has 13 added to it to get 9. So F must be -4, because then if it's -4 and it has 13 added, it will end up at +9. So my answers are that D is 5, E is 7, and F is -4. Right, part B. The diagram shows P and Q drawn on the grid. It looks like an enlargement, doesn't it? Describe fully the single transformation that maps P onto Q. Well, it's definitely an enlargement, and it's an enlargement by a scale factor. Well, that's 2 high, and the new one is 6 high. So the scale factor must be 3. Okay, so it's an enlargement. Now I need to give a scale factor by scale factor of 3, but I also need to give a center of enlargement. So I'm going to join up corresponding vertices. That one goes there, right? And let's join up this one. Here you are. That's going to be the center of enlargement, isn't it? Check with this one. There you go. So the center of enlargement is 0, 2. Enlargement scale factor is 2 with center of enlargement 0, 2. Okay. On the grid, rotate shape P 90 degrees clockwise about 3, 5. Well, where's 3, 5? 3, 5 is here. So I have to rotate shape B 90 degrees clockwise. Clockwise, that way, 90 degrees. Now it would be easy with some tracing paper, but I can't use tracing paper on the screen. Now this side here is going to rotate 90 degrees clockwise. So it's currently vertical, so it'll end up horizontal, and it'll end up the same distance, so it'll be here. So that's where that side goes. Right, now this side, which I'll colour green, okay, is vertical, so it's going to end up horizontal, and it's going to go 90 degrees clockwise. So it is going to end up here, which means that my new shape, 90 degrees clockwise, so it's going to end up here. Sorry about that. So my new shape is that one, that one. So that is my new shape, but much easier with tracing paper than it is for me to do it off the top of my head. And that, I'll label your shape R. R, let's just check. On the grid above, rotate shape P, 90 degrees, yes, about 90 degrees clockwise, label your shape R. Yes, I've done all that. And that is the end of question 4. The diagram shows a shaded shape AEBCD, yes it does, made by removing a triangle AEB from the rectangle. Okay, here are some measurements that I'm told, including that angle there. Work out the perimeter of the shaded shape. Right, well, if I will need to know the perimeter, then I know this length already. I know that length. I know that length. I don't know DC, but I do know AD is 6. So the only length that I need to find is this length here, DC. Now I can find that length by looking at the top right angle triangle here, by looking at this right angle triangle, and using Pythagoras to find AB, because DC will be the same as AB. So I'm going to be analysing the triangle ABE using Pythagoras. This side is the hypotenuse, so I need to find the hypotenuse AB. So AB squared will be 7.2 squared plus 5.4 squared. So AB squared is 7.2 squared plus 5.4 squared is 81, which means that AB is the square root of 81, 9. So AB is 9, so that's 9, and that's 9. So the perimeter of the shaded shape is going to be as follows. I'll start here, and I'm going to move 7.2, 5.4, 6, 9, and 6. So the perimeter will be 7.2 plus 5.4 plus 6 plus 9 plus 6. So let's add that little lot up. 7.2 plus 5.4 plus 6 plus 9 plus 6 gives me 33.6 centimetres. 33.6 centimetres. Let's just have a quick check. It said work out the perimeter of the shaded shape, and I've done that. And that is my answer to question 5. Question 6, simplify. Well, this is something cubed, so it's going to be the something multiplied by the something multiplied by the something. So it's going to be 2 times 2 times 2, which is 8. C to the 4 times C to the 4 times C to the 4, which is C to the 12, add the indices, and D to the 21. Find the value of 5 times y to the power of 0, where y is positive. Well, y to the 0, anything to the 0 is 1, isn't it? So 5y to the 0 is 5 times 1, which is simply 5. Factorise fully. Right, what factors will go into both of these expressions? Well, 4 will, a squared will, and b will go. That's what will go into both of them. And if I divide this first expression here by 4a squared b, I get the answer 4b squared. And if I divide the second expression, 20a cubed b, by 4a squared b, I get the answer 5a. And to check my answer in my head, I could just multiply out this bracket and check. I would get back to what I started with. 4 4s are 16, a squared b will give me a squared b cubed, yes it will. 4 5s are 20, a squared b multiplied by a is a cubed b. Good, that's that one done. Factorise. Right, I need to multiply to minus 22. I'm multiplying to a negative number. It's going to be single x, by the way, because it's single x squared. If I'm going to multiply to a negative number, I must have one positive and one negative number here. And my two numbers have to add to plus 9. So the answer is going to be plus 11 and minus 2, because that will give me a product of minus 22. And when I multiply that out, it'll give me plus 9x. Hence, so use that answer, solve this quadratic equation. Well, you know to solve a quadratic equation, set it equal to 0. It's already set equal to 0, isn't it? So factorise the left-hand side. Well, I've already done that. So my two answers are x equals minus 11 or 2. And that is question number 6 complete. The region R, shown shaded in the diagram, is bounded by 3 straight lines. Find the inequalities that define R. Right, well, the first thing to notice is that all the lines are solid. So that means that my inequalities are going to be greater than or equal to, or less than or equal to, because the points on the solid line are included in the region. Right, let's start off with this line here. And let's work out the equation of that line. Well, I'm going to do y equals mx plus c. M is the gradient, and the gradient of this line is 2, because when I go 1 along to the left, the line goes 2 up, and the y-intercept is plus 4. So the equation of that line is y equals 2x plus 4, and I am interested in points beneath it. I'm interested in points where y is less than or equal to 2x plus 4. Right, now let's have a look at this blue line here. Well, this blue line crosses the x-axis at 1, so it is the line x equals 1, and shaded are points to the left of that, so x is less than or equal to 1. And now let's have a look lastly at this red line here. This is the line that crosses the y-axis at minus 2, so it's the line y equals minus 2. And I'm interested in points above that, points which have a y-coordinate of greater than or equal to minus 2. So there are my 3 inequalities. Write 300 as a product of its prime factors, showing you're working clearly. So I can't use my calculator to just produce an answer. I need to show my working clearly. Well, 300 is 30 multiplied by 10. 30 is 6 5s, 5s are prime. 10 is 2 5s, both of those are prime. And 6 is 2 3s, which are both prime. So 300, written as a product of prime factors, will be 2 times 3 times 5 times 2 times 5, which you could always write as 2 times 2 times 3 times 5 times 5, which you could always write as 2 squared times 3 times 5 squared. Okay. Now, A is equal to 2 times 2 times 2 times 3 times 3 times 5, and B is equal to 2 times 2 times 3 times 3 times 3 times 5. Find the lowest common multiple of 5A and 7B. Okay, well, 5A will be whatever A is multiplied by 5, and 7B will be whatever B is, that's B multiplied by 7. So in fact, I'm being asked to find the lowest common multiple of these two numbers, 5A and 7B. Let's have a look at the 2's first. I've got 2 cubed here and 2 squared here, so I'm going to need to have 2 times 2 times 2 in my number if my number is to divide by 5a and also divide by 7b. I'm going to need 3 cubed because I've got 3 cubed, 3 times 3 times 3 in one of my numbers. I'm going to need 5 squared, and I'm going to need a 7. So that is the lowest common multiple of 5a and 7b. 2 times 2 times 2. It doesn't say give my answer in prime factors. It doesn't say I can't, but I'll work out what that is in any case on my calculator, and the answer is 37,800. So that is the lowest common multiple of 5a and 7b. Solve the simultaneous equations. Show clear algebra working. Now, my method is always to get the x's equal and then subtract. But you might instead like to multiply equation 2 by 3, so you get 9y's in both equations, and then subtract one equation from the other. But I'm going to stick to my method of getting the x's equal and then subtracting. So I'm going to multiply the top equation by 7. Gives me 14x plus 63y equals 7 times 14.5, 101.5. And I'm going to multiply the second equation by 2, gives me 14x plus 6y equals 16. So now I'm going to subtract my equation. I'm going to do my top equation, subtract my bottom equation. I'm going to write in my minus signs, so that gives me 63y minus 6y is 57y, and that equals 101 minus 16, 85.5. So divide both sides by 57, gives me y equals 1.5. Okay, now if y equals 1.5, then I'm going to use equation 1. I'm going to substitute in y is 1.5, so it's going to be 2x plus 9 times 1.5, 13.5, equals 14.5, minus 13.5 from both sides. Divide both sides by 2. Now to check my answer, I'm going to substitute y equals 1.5 into equation 2 and see if I get x equals 1/2 again. So that's going to be 7x plus 4.5 equals 8. So 7x is 8 minus 4.5, which is 3.5. Divide both sides by 7, and again I do get x is 1/2. So my answers are x is 1/2 and y is 1.5. And there's my solution to number 9. Number 10. The test marks of 15 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I see they're in numerical order. Find the interquartile range. Right, well, the median of 15 is going to be the 8th. 1, 2, 3, 4, 5, 6, 7, 8. That's the median because it's the one with 7 either side. So the lower quartile is going to be 15, middle term the first half here, and the upper quartile is going to be 25. So the interquartile range will be 25 minus 15 equals 10. The curve C has this equation. Find dy by dx. Find the gradient function. Right, well, dy by dx will be 3 times 4 is 12x squared plus 2 times 1 is 2, x to the 1, minus 20. So that tells us the gradient for any given value of x. That's the gradient function. And part B says find the x coordinates. There are obviously going to be 2 points, perhaps. Find the x coordinates of the points on C where the gradient is 4. So I need to find what x values make this gradient function equal to 4. So I need to solve this equation. Now it says show clear algebra thing that there are going to be fractional or whole number answers to this quadratic equation. I'm guessing I'll be able to factorise it. Right, let's set it equal to 0. 12x squared plus 2x minus 24 equals 0. Divide over 2 to make it more straightforward. Equals 0. And now we're looking to factorise the left-hand side. Now you can factorise the left-hand side, but rather than simply writing down what it is, I'm going to use the formula just to show you that you could, of course, use the formula x is minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, that's going to be minus 1 plus or minus the square root of b squared 1 squared minus 4 times 6 times minus 12 all over 2 times a is 12. So that gives me minus 1 plus or minus the square root of, and that bracket comes to 289 all over 12. Now the square root of 289 is 17. So the two x values I have are minus 1 plus 17 over 12, which is 16 divided by 12, which is 1 1/3. Or minus 1 minus 17 over 12, which is minus 18 over 12, which is minus 1/2. So those are my two x values. Let's just check what it says. Find the x coordinates of the point. There we are. So the x coordinates are 1 1/3 or minus 1/2. And if you were somebody who factorised that, then you would have been able to factorise it to, let's have a look, it's going to be 3x minus 4 lots of 2x plus 3. That's what your factorisation of the left-hand side there should have looked like. But anyway, I did it with formula, and there's my solution to question 11. The cumulative frequency graph shows information about the heights in centimetres of 50 plants. So here are the 50 plants up the y-axis, and here's the height. Use the graph to find an estimate for the median height of these plants. Well, if there are 50 plants, then the median one, I'm going to look for the height of the 25th. So I'm going to draw a line across here to see what that gives me. Okay, so my estimate for the median is going to be 28 centimetres. Use the graph to find the frequency for the class interval between 30 and 40. Well, let's have a look and see how many I have with a height of 30 or less. That's interesting. I have 30 with a height of 30 or less. So the height of 30, I have a cumulative frequency of 30. And what about when the height is 40? Let's have a look. When the height is 40, I'm going to have a cumulative frequency of 44. Which means that there must be 14 in that class interval. Use the graph to find an estimate for the number of plants with a height greater than 35. Right, height greater than 35. Well, it looks to me as if there are 38 plants with a height of less than 35. So the answer must be the 50 plants minus 38, which are less than 35, gives me 12 plants which have a height of greater than 35 centimetres. A is the point with coordinates minus 5, 12, and B is the point with coordinates 19, minus 48. Find an equation of the straight line that passes through A and B. Right, well, it'll often help to have a sketch, so let's do a sketch here. So we're going to have A at minus 5, 12. And B is 19 along and at minus 48. There we go. And I'm asked to find the equation of the straight line that goes through A and B. This line. Okay. Right, well, I'm going to start by finding the gradient. Okay, the gradient of this straight line. So the gradient is going to be the rise over run. Now, the rise, minus 48 to 12, is 60. And the run, minus 5 to 19, is 24. But my gradient is obviously negative, isn't it? Because I move along positively, my line goes down. So the gradient is minus 60 over 24, which is minus 5 over 2, or minus 2.5. Okay, now I can simply use my equation y minus y1 equals mx minus x1, where x1, comma y1 is a point on the line, so I'll call that minus 5, 12, where m is the gradient, so it's going to be minus 2.5. So I'm going to have y minus 12 equals minus 2.5 lots of x minus minus 5, x plus 5. I'm going to double both sides, gives me 2y minus 24 equals minus 5 lots of x plus 5. 2y minus 24 equals minus 5x minus 25. Add 5x to both sides, 2y plus 5x, and add 24 to both sides, minus 25, add 24 is minus 1. So my line is 2y plus 2y plus 5x equals minus 1. Or if you did it in terms of y equals mx plus c, you would have had y equals minus 5 minus 2.5x minus 5 over 2 x minus a half, which would be the same. Question 14, factorise fully. I wonder if once I take something out, I'm going to be left with the difference of two squares or something like that. Let's have a look. So I've got 50g squared minus 18. Well, clearly all I can take out is a numerical value, isn't it? 50 and 18. I can take out 2. It's going to give me 2 lots of 25g squared minus 9. Aha, that's the difference of two squares, isn't it? So 2 lots of 5g plus 3, 5g minus 3. So there is my answer. 2 lots of 5g plus 3, 5g minus 3. Number 15. Work out the value of n. Here's n. Show you're working clearly. Looking at the left-hand side here, I'm going to more or less put everything into base 2. Now the square root of 2 is 2 to the power of half. I've got that divided by, now 8 to the power of 3. 8 cubed is 2 cubed, which is 2 cubed times 2 cubed times 2 cubed, which is 2 to the power of 9. So instead of writing 8 cubed, I'm going to write 2 to the power of 9. Now 16 to the power of 3 over 2. Well, that's the square root of 16 cubed. So that is 4 cubed. And 4 is 2 squared. So it's 2 squared times 2 squared times 2 squared, which is 2 to the power of 6. Now, 2 to the half divided by 2 to the 9 divided by 2 to the 6 is 2 to the power of 3, subtracting the indices. 2½ divided by 2 to the power of 3. A half minus 3 is minus 2½. So that's 2 to the power of minus 2½. So 2 to the power of minus 2½ equals 2 to the n. So what's n? N is minus 2½ or minus 5 over 2. Part B. Find 4% of this number. Well, 4% of that, lots of different ways of doing it, but 4% of is 1/25th of, which is simply the number divided by 25, isn't it? So I've got to do 4.5 times 10 to the power of 157 divided by 25. It's a shame that there isn't a 100 here. I could just divide 25 into, but of course there is, because I could write that as 4 to the 5 times 10 times 10 times 10 to the power of 155 all over 25. And now the 25 will divide into the 100 4 times. So I'm left with 4.5 times 4 times 10 to the power of 155. Well, 4.5 times 4 is easy enough. 18 times 10 to the power of 155. Now I must give my answer in standard form. So I'm dividing that one by 10. So I'm going to multiply this one by 10. So my answer is 1.8 times 10 to the power of 156. Okay, that is my solution. Question. The Venn diagram shows the universal set and sets A, B, and C. The numbers and the letter X represents the numbers of the elements. Right, so for instance, there are 9 elements here. Okay, given that the number in A union B equals 42, find the value of X. Well, that means that all of these numbers added together must equal 42. So X is equal to 42 minus 9 minus 5 minus 3 minus 7 minus 12. So X is equal to 42 minus 9 minus 5 minus 3 minus 7 minus 12. So X is equal to 6. Okay. Find the number which are not in A. Well, that's going to be those ones, those ones, those ones, and those ones. 17, 24, 36. So the answer is 36 elements and not in A. Okay. Find the number which are not in B and also in C. Not in B and in C. So not in B and in C. These 15 elements are in C, and they're also not in B. So the answer is 15. And that is question 16. The functions g and h are defined here. In the function h, x is greater than or equal to 0. Okay. What value of x must be excluded from any domain of G? And the answer is any value of x which makes the denominator equal to 0. So any value of x which makes that equal to 0, i.e. x is 2½ or 5 over 2. Solve gh of x equals 1. Right. Well, g of x is 11 over 2x minus 5, and we know that h of x is x squared plus 4, where x is greater than 0, greater than or equal to 0. Okay, so the g of h of x, if I g h of x, I end up with 11 over 2 lots of x squared plus 4 minus 5, and I know that that has to equal 1. Let's simplify the denominator here, 2x squared plus 8 minus 5, and that equals 1. So that's 11 over 2x squared plus 3 equals 1. Multiply both sides by 2x squared plus 3, and minus 3 from both sides. Divide both sides by 2 equals x squared, so x would equal plus 2 or minus 2. But I know that x must be greater than or equal to 0. So x must be greater than or equal to 0 implies that x equals 2 rather than minus 2. So my solution to the equation is x equals 2. And that is question 17. Finished. The incomplete table and incomplete histogram give information about the times in minutes that 140 people waited at a station. So I've got some people waited between 0 and 5 minutes, 23 people. Their bar isn't shown. Those who waited 5 to 15 minutes, here they are. 15 to 30, here they are. Meanwhile, I know how many waited between 30 and 40, but I've got no entry on the histogram. And similarly, 40 to 60, I've got no entry on the histogram. Right, now histograms are always all about areas. So let's work out the area of the bars that I know. This bar is 10 wide, and it's 10, 20, 25 high, so 250. That's an area of 250 of the small squares. And this second bar is 15 wide, 10, 20, 30, 40, 40 high. 15 times 40 is 600. So altogether, the area of these two bars is 850. 850 squares. Now, how many people does that represent? Well, let's have a look. I have got 140 people in all. Now, if I take away 23, 18, and 14 from 140, I have 85 left. So I know that these 850 squares represent 85 people. So 10 squares a person, which means that this one here has to be 230 squares. Well, let's have a look. This part of the histogram here is 5 squares wide, isn't it? So 230 squares, it's going to need to go up to 46. 10, 20, 30, 40, 46. So here is the bar for this one, going up to 46. Okay, that's the frequency density of 46. Right, okay. I better label the scale. 10, 20, 30, 40, 50. Okay. 30 to 40, well, that's 18 people. So it's a frequency density of, well, it's 18 people, so it's 180 squares. Now, the class width is 10. So to get 180 squares, I'm going to have a frequency density of 18, aren't I? So here we go. Frequency density of 18. 10, 18 is up to here. There we go. So that's the 30 to 40 people. Right. Now, 140 squares. And I see that it's 20 wide. So I'm going to have to go up to 7. 5, 6, 7. There we go. So let's just see if I've done everything I was supposed to do. It says complete the table. Right, so I better complete the table here. So this is 25 people there and 60 people there. And complete the histogram. Well, I've labelled the scale there. I've and I've completed the histogram. So I think I've completed the table and I've completed the histogram, and that's my solution to question 18. So M is the midpoint of OA, and ON is a fifth of the whole length. So it's going to be worth noting now that OB is 6 times the vector B. It's also going to be worth realizing that because these are straight lines here, that from B to P is a fraction of B to M, and in the same way, A to P is going to be a fraction of A to N. Right. Okay, let's move on. Part A. Find in terms of A and B the vector A to N. Well, if I were going from A to N, I would first of all go an A backwards and an A backwards, and then a B forwards. So it's going to be 2 backwards A's plus a B, which we might like to write as B minus 2A. Okay, use a vector method to find the ratio AP to PN. That's the ratio of AP to PN. Okay, now I'm going to do this by finding two expressions for the vector OP, O to P. I'm going to go from O to P in two different ways. The first way is going to be the way that's been hinted at by part A. I'm going to go from O to A and then down to P. Let's have a look at that. It's going to be O to A and then A to P, not the full way A to N, A to P, right? So that's going to be O to A is 2A, and then A to P is a certain fraction of A to N. Now I know A to N here, so A to P I'm going to call mu a certain fraction of that vector. Good. Okay, now I'm also going to go from O to P in a different way, using this fact here about the ratio. Now, I'm going to go from O to B, and then I'm going to go from B to P. Let's have a look at that. So, that means that OP is going to equal O to B is 6B. Fine. Now I have to go from B to P. That's going to be a certain fraction of B to M. Let's just work out B to M here, shall we? B to M. Now to go from B to M, I'm going to go backwards there and forwards here. So it's going to be minus 6B plus an A, or you might like to call that A minus 6B. So that's B to M. So B to P is going to be a certain fraction of that. I'm going to call it lambda that. So B to P will be plus lambda, a certain fraction of A minus 6B. Okay. Right, now I've got two expressions here for OP, so I'm going to put them equal to each other. So I have 2A plus mu B minus 2A equals 6B plus lambda A minus 6B. Let's multiply out those two brackets. And then in a moment, we're going to put the coefficients of A and the coefficients of B equal to each other. Now, on the left-hand side here, let's just make sure we don't make any mistakes. So I'm going to pull those two terms which involve A next to each other. And I'm going to pull these two terms which involve B next to each other. Right, now I'm going to work out what the coefficient of A is here by factorising. So I've got A lots of 2 minus 2 mu plus mu B equals factorise here. Take the B's out, see how many B's there are altogether. That many B's altogether, plus lambda C. Right, now I know that the coefficient of A must equal the coefficient of A. And I know that the coefficient of B must equal the coefficient of B. So that means that 2 minus 2 mu equals lambda. And it also means that mu equals 6 minus 6 lambda. Good. Okay, I'm going to take this expression for lambda, substitute it into the second equation, which is going to give me 2 minus 2 mu, instead of the lambda here, equals, it's not, beg your pardon, it's going to give me mu equals 6 minus 6 times 2 minus 2 mu. Okay, multiply out that bracket and we can solve this equation to find mu. Go with your bracket. So I'm going to subtract mu from each side. I've got minus 6 on the left hand side, so plus 6 to both sides. I get 11 mu equals 6. So mu is going to equal 6 over 11. Now, this is important. So mu is 6/11. Now, mu was the fraction of the whole that was AP. So AP is 6/7 of AN. AP equals 6/11 of AN. Let's just have a look at this. So here is AN, looking like this. And AP is 6/11 of that, which must mean that this part is 5/11 of it, which means that the ratio AP to AN, the ratio AP to PN is 6 to 5. AP to PN is 6 to 5. And there is my solution to question 19. The sum of the first 80 terms of an arithmetic series is 470, and the 75th term of the same series is 14.5. I'm going to be able to write two equations there and find A and D, I think. And then the questions coming up. The sum of the first x terms of the same sequence is 171. Work out the value of x. All right, let's use these two yellow facts to write some equations down. First of all, if the 75th term is 14.5, well, I know that the nth term of a series is the first term plus n minus 1 times d, where d is the constant difference. So in this case, I'm going to have a plus 74d, and that is going to equal 14.5. So there's one equation. Let's write that over here. A plus 74d equals 14.5. Now the other equation is going to come from this first yellow fact here, that the sum of the first 80 terms, well, I know the sum of the first n terms is n over 2 times by 2a plus n minus 1 lots of D, and this is the sum of the first 80 terms. So it's S80 going to be 40 times 2A plus 79 times D. 79 times D, and I know that that equals 470. So that's going to be 80A plus 79 times 40, 3160D, and that's going to equal 470. Right, so here's another equation. Let's write that one over here. 80A plus 3160D equals 470. So I'm going to solve these equations simultaneously to find A and D, and then I'll know all about the sequence. I'm going to multiply the top equation by 80, which is going to give me 80A plus 74 times 80 D equals 14.5 multiplied by 80. Okay, now I'm going to do my red equation, subtract my green, the bottom one minus the top one. It's going to give me no A's. 5,920 minus 3,160D gives me 2,760D, and that equals 690. So D is a quarter. Great. So I know what D is now, and I'm going to substitute that into the top blue equation here. Here was the blue equation. A plus 74D equals 14.5. Substitute in D is a quarter there. 74 times a quarter, 74 divided by 4 equals 14.5. So A is minus 4. So now I know what my sequence looks like. It's got a first term of minus 4, and the constant difference is a quarter. Okay. Right, let's go back to the blue question now. It tells me that the sum of the first x terms. So let's make this, give myself a little room here. The sum of the first x terms, which would be x over 2 multiplied by 2a plus n minus 1 d, is 171. Well, just a moment. So that's going to give me x over 2 multiplied by twice a, it's minus 8, plus x minus 1 times by a quarter. That's going to equal 171. All right. So having a look at that equation, I'm going to start by multiplying everything by 2, I think. So I'm going to double the left-hand side, which just gets rid of the x over 2, and that just becomes an x now. And the right-hand side becomes 342. And I'll multiply out the bracket as well. So I'm going to have x times minus 8, minus 8x, plus x times x minus 1 times a quarter. And that equals 342. Multiply everything by 4 now, get rid of that quarter. It's going to give me minus 32x, plus, I might as well multiply out this bracket, x squared minus x equals 4 times 342, gives me 1368. This is going to be a quadratic equation now. Set everything equal to 0. X squared minus 33x minus 1368 equals 0. Right, I'm going to have to factorize this. Well, I know that it can look like that, and I'm going to have a plus and a minus because my product is negative here. And I know my two factors of 368 are going to need to have a difference of 33. So I've got minus 33x. So it's actually going to be 24 and 57. That gives me a product of minus 1,368, and it gives me plus 24x's, minus 57x's, minus 33x's. So that's all good. So my solutions are that x equals minus 24 or 57. However, let's just go back to the question. The sum of the first x terms is 171. Find the value of x. Well, clearly, you can't have the sum of the first minus 24 terms. So the solution is that x must be 57. So the sum of the first 57 terms, which is 170. A curve has equation y equals f of x. There is only one turning point, and the coordinates are 6, 5. Write down the coordinates of the turning point on the curve with the equation f of x minus 4. Well, if the coordinates of the turning point, let's just assume it's a maximum for the purposes of this drawing. If the coordinates are at 6, 5, there they are, then x minus 4 will move the curve to the right 4 places. So this will be the new turning point. So the new turning point would be at 10, 5, rather than at 6, 5. Okay. Now, what about if instead we had y of f of 3x? Well, we know that the maximum is going to occur when we are f'ing a value of 6. So we want to f6. So if we're f'ing 3x, then we want x to be 2. Okay, so the turning point would be at 2, 5, rather than at 6, 5. And that's question. Okay. You've got a circle, and you know that half the area of the circle is shaded and half is not, because the shaded area is the same as the unshaded area. Altogether, those two areas equal the area of the large circle. And you know the pentagon's got sides of 8. You need to find the area, the radius of the smaller circle. Let's start off by looking at this pentagon. And in particular, let's look at, here's one edge of the pentagon, and here is the center of the circle. Oh, that's 8. Now, because it's a pentagon, its angle at the center is 72, which means, incidentally, that each of those angles is 54. Also, this length here, which I'll call x, is the length from the center to there. That's the radius of the circle. Okay, let's find that length x. I can do that using the sine rule. I've got 8 over 72. Sorry, 8 over sine 72 equals x over sine 54. So that gives me x of 6.8054 and so on. So now I know the radius of the circle. The radius of the large circle is 6.8054, which means that I know that the area of the large circle, pi r squared, is going to be 145. And worth just jotting down some remaining digits on your calculator for later. Okay, so I've got the area of the large circle now, which incidentally means that I know the area of the shaded part and the area of the unshaded part. Each of those is half the area of the circle, isn't it? 145.4895027 divided by 2. So each of these here is 72.74475135. Okay, square centimeters. All right. Now that I know the radius of the circle, that means that I can find the area of the pentagon, because I can find the area of this triangle and multiply it by 5. So let's find the area of the pentagon, because then I'm going to subtract that away from the area of the whole circle, and that will give me the area of those 5 shaded parts there. So let's start with the area of the triangle. Well, the area of a triangle the area of one of those triangles is going to be a half times b times c times sine a. So half times 6.8052 times 6.8052 times sine of 72. So the area of one of those triangles is 22.022 and so on. So the area of the pentagon is 5 times that, which is 110.11055536. So that's the area of the pentagon, which means that I can find the area of these 5 shapes. So the area of the 5 shapes is going to be the area of the circle, 145-ish, subtract the area of the pentagon, which is 35.37894,908. Right, now I know that the area of my 5 shapes here, this 35, plus the area of the circle, of which I want to know the radius, is equal to half the area of the large circle. So I know that the area of my 5 shapes I've just found plus the area of my inside circle, my small circle, has to equal 72.74475135, which tells me that the area of my circle must be 37.365. So my radius squared is 11.89, and the radius of the small circle is the square root of that, which to 3 significant figures is 3.45 centimeters. And there is my solution to question 22. Okay, we're going to remove this square-based pyramid, the smaller one, from the top of the larger square-based pyramid, the similar large square-based pyramid, and we're going to then find the surface area of the shapes that's left. Okay, we're given some heights, and I noticed that the smaller square-based pyramid is a third of the height of the larger one, so all the lengths will be a third. So I can instantly see that this square on the top is going to have sides of 13. So when I'm thinking about the surface area of the solid on the bottom, I have already got 39 squared for the square on the bottom and 13 squared for the square on the top. So all I'm left with is having to find the area of 4 trapeziums or trapezia, like that. The bottom is 39 and this top length is going to be 13, and I'm going to need to find the height here of the trapezium. Now that's not going to be terribly easy without finding this length, which I'll call AB first. Incidentally, it's an isosceles trapezium. Right, this height, this length AB is the same as this length here, AB, and it's going to be 2/3 of the length of C to B. So I'm going to find the length of C to B. I'm going to do that by dropping a perpendicular all the way down here to the center of the base, and then drawing this blue line here. Now that blue line is half the diagonal. So the length of the blue line, which I'll call DB here, is half the diagonal. So DB is going to be, the whole diagonal will be the square root of 39 squared plus 39 squared. That 39 squared plus 39 squared is 3042. So dB will be half of that. So dB, the base of my right angle triangle, is going to be the square root of 3042 over 2. Now, I'm going to need to use that to find the length CB. And of course, I've omitted to label in my diagram that CD is 45. So I can now find CB as it's the hypotenuse of that triangle. So CB squared will be dB squared, square root of 3042 over 2 squared, plus 45 squared. So CB squared is 3042 over 4 plus 45 squared, which means that CB is the square root of 2785.5. Okay, so now I know what CB is. That means I can find AB, because AB will be 2/3 of CB, because AB is a certain, it's because the top square base pyramid is 1/3 of the whole length, isn't it? So what is going to be left, AB, is 2/3. So I've got AB equals 2/3 of the square root of 2785.5. So now I know AB. Let's get back to my diagram here and see how that helps me. So I had a trapezium. Let's draw it a bit larger. There we go. It's 13 along the top, 39 along the bottom, and I know this length here, the sloped height, is 2/3 square root 2785.5. Right, I know it's an isosceles trapezium, so that means that I can now find this height, because I know that this length here is going to be 39 minus 13 divided by 2 is 13, which enables me now to find the height of the trapezium by using Pythagoras. I've got the hypotenuse here, the height, and 13. So the hypotenuse squared is 2/3 multiplied by that square root squared minus 169, which gives me a hypotenuse of the square root of 1069. So now I can find the area of the trapezium. The area of my trapezium is going to be the average of the horizontal lengths, 13 plus 39 over 2 times by the height. And if I'm going to find the surface area of the whole of the solid, then I've got 4 of those, plus the square on the top, which is 13 squared, and the square on the bottom, which is 39 squared. So that is an expression for the surface area of the shape I was asked to find the surface area of. So a bit of calculator work, and I discover that the answer is, let's have a look, 13 plus 39, 52 divided by 2, so I get 26 times square root of 1069 times by 4, and then onto that I'm going to add 169 to add 39 squared. Gives me an answer of 3,390.169 and so on, and I was asked to give the answer correct to the nearest whole number, So my answer will be 3,090 square centimetres. And that is my solution for number 23. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.